Hi and good day, Dr. Siti Rosmaniza. We're from Group B, and the title of our project is Smart Home Appliances Communication System. Next. So let me introduce our group members. First is Lim Fang Gualmi, and then second, IZZUDDIN.
Hi.
Next is ADHA BATRISYIA,
Hello.
and then FAJRINA.
Hi.
Lastly, HAZIRAH.
Hi.
Then we'll continue with our introduction.
So the introduction is Wi-Fi enabled device to connect and exchange data wirelessly over networks. Then the ESP8266 module is a low-cost Wi-Fi enabled microcontroller that connects smart home device to the network. It uses a PCB antenna for wireless connection. The smartphone acts as the control center for smart home device. The Blink apps on the smartphone allows users to control and monitor their smart home system. The ESP8266 module receives commands from the smartphones and controls the connected device accordingly. Communication between the smartphones and the ESP8266 module happens seamlessly over Wi-Fi, provide flexibility and convenience. So that's the introduction. Thank you.
Okay. Next is objective to investigate the Wi-Fi communication using the microcontroller ESP8266. Second, to understand the operating frequency and bandwidth of Wi-Fi communication. And then third, to investigate how the wireless communication between smartphone and ESP8266. Lastly, to develop a wireless smart home appliances communication system utilizing smartphone as remote control device. Next is our methodology. I will start by introducing the component and software used in this project. First is ESP8266, serve as a microcontroller, and then PIR motion sensor, servo motor, 2 LEDs, 2 registers, jumper wires, breadboard, and a smartphone. The model is Oppo F56V, and then micro USB cable and Blink application. To briefly elaborate the working of this system, it's called Smart Home Appliances Communication System, right? So yeah, of course, it allows users to control their appliances using their personal device. It can be their phone, their tablet, or even laptop. It has 3 basic features. First is home surveillance. Second is home remote control appliances. And then lastly is send notification via Blink application. With a simple touch on the virtual button on your phone or your tablet, you can switch on and switch off the lights without going to a specific place where the button is to control the switch. So it eases the life of user tremendously, so they don't have to go to a specific place to turn on and turn off. And it also at the same time reduce the chances of getting electric shock as well. The system also include gyro motion sensor for the home surveillance, and then it will send notifications through Blink app to notify the user if there is anyone entering the home. That's all for working system.
Thank you, Lim, for your great explanation. So next, we move to result and finding. So based on figure 2.0, this is a plot diagram for our system. We use ESP32 as our transmitter and receiver, and we use a smartphone for control the input and output for our system. So figure point 2 is the circuit diagram for our system. Figure 2.2, which is hardware circuit construction. This is real hardware used to make the smart home appliances. So the connection between ESP32 and phone or tablet that we use is same Wi-Fi network to control the LED and servo, which is our output, and to monitor our input, which is the motion sensor. Okay, so for the operation frequency, the NAIM MCU that ESP8266 that we use for our system can support Wi-Fi network at 2.4 to 2.5 GHz, and the input frequency for the Wi-Fi chip is between 2400 to 2483.5 MHz. So for the bandwidth, the highest bandwidth that the Node MCU can support, which is 72.2 megabit per second in 20 MHz channel bandwidth, and 150 megabit per second in 40 MHz channel bandwidth mode. The third one, which is transmit power. So the ESP8266 module have a transmit power of around 25 dBm or decibel milliwatts, which correspond to roughly around 0.316 watt.
Next, for discussion, Wi-Fi enables seamless connectivity and data exchange between devices in the IoT era. The ESP8266 module acts as a low-cost Wi-Fi interface for smart home devices. The smartphone serves as the control center, allowing users to send commands and receive feedback. The Blink app provides a user-friendly interface for controlling and monitoring the smart home system. Wireless communication between the smartphone and ESP8266 occurs over Wi-Fi, ensuring flexibility and convenience. The ESP8266 module translates commands from the smartphone to control connected devices. Factors like frequency, bandwidth, and transmit power affect the range and performance of the ESP8266 module. A wireless smart home system using a smartphone as a remote control offers convenience and remote monitoring. Wi-Fi networks provide reliable connections, and TCP or IP support enables communication over software platforms like Blink, optimize communication and create intuitive interfaces. So for the transmitter, which is the smartphone serves as a remote control device for smart home appliances. Like the user interacts with a smartphone application such as Blink that we use to send a command or instruction. So the smartphone generates a wireless signal containing the command or the instruction. Then the signal then transmitted through the smartphone Wi-Fi antenna, and the Wi-Fi signal travels through the air to reach the Wi-Fi router in the home. And the Wi-Fi router acts as an intermediary, receiving and transmitting signal within the local network. And lastly, the router forwards the combined signal to the ESP8266 module. So for the ESP8266 module, which is the receiver, is a Wi-Fi client connecting to the user's Wi-Fi network. It receives the command signal sent by the router. The ESP8266 module's onboard antenna capture the Wi-Fi signal in the 2.4 GHz frequency range. Upon receiving the signal, the ESP8266 module processes the command within its microcontroller Then the module performs the corresponding action, such as activating a relay or switch connected to the appliance. So the ESP module can also transmit the data back to the smartphone, such as status update or sensor reading. It uses its antenna to send Wi-Fi signal back to the Wi-Fi router, which relay the signals to the smartphone. That's it for the discussion.
Okay, I will continue with the conversion. The smart home applications communication system use Wi-Fi and the ESP8266 module to connect smart appliances with smartphones. The ESP8266 module establishes Wi-Fi connection and encodes data for transmission. Smartphones receive and process the wireless signal using the Blink apps. Two-way communication ensures reliable data transfer. Additional components exchange security, automate gate operations, and control light. The PIR motion sensor detects movement and sends alerts. The servo motor enables remote control of gates to convenience and security. LED allows remote control and customization of lighting. The system offers convenience, comfort, and security in customizable smart home environment. That's all for conclusion.
Alright, so that's all for our video presentation. Next will be our demo demonstration, so yeah, don't leave. Thank you. And yeah, another, again, thank you from Group B.